Hello everyone, welcome back to number 3 of this whatever introduction to how to do stuff series that I'm doing here. Today we actually are going to write some code and going to go through all the stuff that goes along with it. So we're going to learn the general gist of how a program works in the real world. Go through the hello world example. Now a hello world is basically what you do when you learn a language. You do a hello world example. It teaches you a lot of the basic concepts of a language, and sort of gets up that syntax in your brain so you actually remember stuff. We're going to go through function entry points, and I'll explain those. Certain things like data types and other functions and stuff. We'll go through those in relation to what we're doing, and also talk about some of the little magic things that you need to do to make code work. So before we go on to that, I will apologize. My voice is a bit knackered, coming down with something, but we will move on. So I'm going to assume you have all installed Visual Studio 2017 by now, at least the Community Edition. It is free, and it is very good if you're on Mac or Linux, or even on Windows and you're using Visual Studio Code or something else. These examples will obviously not apply, but I'm sure you can figure it out. So let's go through and start our first project. So we're going to go File, New, Project, and I'll explain what all this is as we go along. We're going to create a Visual C++ empty project. I'm going to put it in my C drive because I have a folder to it. And I'm going to call it ITC, Intro to Coding, Lesson 1. Now I'll go through what all this means in a second. So what have we got down here? The location, that should be pretty self-explanatory. That's where it's being stored. I would highly recommend if you have an SSD or some kind of fast scratch disk that you store it on there. It'll speed up a lot of what you're doing. With the stuff we're doing, it doesn't matter too much. It's not very big, but definitely in like a more production kind of big application environment, it will definitely be something you want to do. Now there's a name and a solution name. So the solution name, or a solution in general, is a big grouping of projects. So in the case of what I'm doing, I'm calling ITC, it's Intro to Coding, and that's going to contain all of my lessons. Now this is actually lesson 3, the first 2 didn't technically have any code. So the name in this case is the project name, which is just going to be lesson 3. The project is one subset, one application, one whatever of code that we're going to use. So don't worry about all the rest. We can talk about Git at some point. Actually, I'm going to mark that down, that we should probably talk about source control, because that is an extremely important topic that unfortunately you don't get taught when you go to uni or you go to most things. You don't really find out about it until it's too late. So let's go empty project and let's see what we got. Come on. Okay, there we go. It didn't name my solution properly. I'm upset. We'll just rename it. Okay. So as you can see here, we have this top level solution ITC, which I've just renamed. And the hotkey to rename in Windows is F2. It works in files, folders, and all that kind of stuff. And most Microsoft programs also use the same hotkey. Then we have the project itself, lesson 3. You'll notice the ++ symbol here. As you do different languages, they come with different symbols, so you can quickly check what's what. Then we got this references folder, header, resources, and source files. We're not going to worry too much about what the difference between all these things are at this point in time, but we definitely will go through it at a later date. Let me just move this mic a little bit so I can make sure my VU meter is still going up and down. And yes, so what do we do now? We have a blank project. We've basically got an empty notebook or an empty folder, actual binder folder, not like a computer folder. I guess same kind of thing. Let's add some shit to it, shall we? We're going to add something to the source files. So we're going to go right click that, add new item. And we're just going to add a CPP file, a C++ file. We're just going to call this main. You can call it whatever you want. You could just leave the default. I will go through a little bit of naming conventions and good practices as we go through. And in the case of this, the The first file you make where the program actually runs from should be called something like main or program or app, something to really designate that this is where it starts. All things that you name should be significant. You should not do blah, or as the guy at work does, haha. Or as I used to do, I used to call everything anus, but that's another story altogether. So let's just call it main and click add. And for some reason my computer's running like dog shit, but that's fine. Let's put my zoom back to 100%. I really hope that you guys can see that. I actually might zoom in a little bit. So what do we have here? Oops. We have an empty text file. Cool. What do we do with an empty text file? What do we do with a drunken sailor as well? But also, what do we do with an empty text file? We write our code. What kind of code we're going to write? Now, as I mentioned before, we are going to do the hello world example. So what is the hello world example? Hello world is when you get the text hello world to appear on screen or somewhere. In the case of something like C++, it opens in a console window. In the case of, like, if you're doing a games engine, you'd get it to display on screen in like text or a 3D model or something of hello world. In the case of something that's running on your phone, obviously it displays on your phone screen. If you've got a terminal or if you've got like a Tamagotchi, you make the Tamagotchi say hello world or some shit, you know, you get the idea. So we're going to do that, and we're going to go through all the code and how to do it. And this is going to be exceptionally long, I think, simply because it's only going to be like 6 lines of code, but the underlying concepts can be a little bit tricky. And because you're basically starting from scratch, we're going to have to go through everything as much as possible. Now, I have this problem where I tend to explain things as low as I can go, but because I've been doing this for so long, I sometimes forget that you can go even lower and lower and lower until people understand it. So I will apologize in advance if I miss any of the finer details, but we will see how we go. So let me just do this. Okie dokie, artichoke. Ignore my Chrome window. I just have some code that I have got in a document written up there because I can never remember hello world. Believe it or not, it's the most simple bit of code and it always falls out of my brain. It's just like, it's honestly like forgetting how to put a key in an ignition to start a car when you're a mechanic. It's the most frustrating thing. But let's move on. So we're going to do one thing at a time, one line at a time, and then we're going to explain it as much as possible. So the first line of code we're going to write, and this is so exciting because you guys, if you haven't done any code before, this is the exact first line of code that I wrote when I started C++. So it was exciting for me back then, and I'm a turbo nerd, so it probably doesn't apply to you. My apologies, my sore throat got the best of me for a second there. So what do we have? And that's another thing you will notice, a quirk of mine. After I type everything, I push Control S because losing work fucking sucks. And it takes no time to save a document in this day and age, so you should be hitting the Control S as much as possible. So what do we got here? We have a simple line of code. It is hash include open angled bracket Iostream close angled bracket. Now, you got to look at that and like, what the fuck are you on about? Good, let's go into it. Let's go from the start because that seems to be the most logical place. If you remember in, I think episode 2? Yes, episode 2, I spoke about the compilation steps, and one of the compilation steps I spoke about was a preprocessor. If you don't remember, I'll give you a quick rundown. The preprocessor is the first stage of compilation. It runs through and just does a bunch of text replace. It's kind of like you pushing Control H, or you go to find and replace, and you're replacing some string with something else everywhere. That's basically what the preprocessor does. The hash indicates that what's coming after it is a preprocessor directive. It tells the preprocessor that, hey, I've got shit for you to do. It's devastatingly simple, but also like super duper complicated than what you could do with it. But yeah, that is what that is. That is telling you that the first compilation step is going to have work to do with whatever's after this. So now we have include. What is include? Now, in real world terms, and the good thing about C++ and why I like it, and I guess a lot of programming languages as well, is it relates very closely to English. There are things in in coding in general, but in C++, I think a lot more, that very closely relate to what their English counterparts would actually be. And this is actually a great example. Include. Include just means, in the case of the preprocessor, go and grab me some data. Include it in this file. And this example is here, okay? So Iostream. Iostream is a document. It is a piece of code that someone else has written. Now, what this does is really not relevant to you. What all of the Iostream code does, like what all this crap does. What's this pure app domain global extern CRT data to import Iostream CN *_PTR_CN semicolon. You don't care what that does. It's completely irrelevant to you. The part that is relevant and why the include directive is used just literally everywhere in C++ is someone else has written a bit of code that you want to use, and they give you certain things that you can do. But for you to be able to do those certain things, you have to know about literally everything about how to do them. Because I can't tell you as the person listening to this to do something unless you know how to do it. And if I'm telling you to do something you don't know how to do, I'm going to have to actually tell you how to do it as well. And you could think about all the things you want to do in a piece of code. So in the case of Hello World, you have to start the program. You have to know how to put things on the screen. You have to know what text means. You have to know how to do, stopping of a program, starting of a program, all this kind of stuff. And if you had to type that in every single time, that would become extremely tedious, and it would be very annoying and extremely messy to have all this crap just in one file. Like you could imagine if you had a book that was 600 pages long and there was no punctuation, no paragraph marks. It was just one long page, just like an old dot matrix printer with the paper that doesn't stop. That would be so tedious. So this include just goes, there is some stuff in this Iostream file that I want to be able to use. Can you please include it for me when you go to compile? I don't need to know what's in there, but you do. That's basically what this does. Now, there is a couple of ways you can use Iostream. There is angled brackets, and then there is quotation marks, and whatever file. This is illegal what I just did, but we'll go with it for now. The difference between these two things, so you're telling me it's illegal now, so it includes itself. The reason these two things are different is this one here, the angled brackets say, go and look in all the usual places. It's somewhere in the project. I've given you a bunch of folders to go search in. Just go have a look. Whereas the quotation mark says it is local. It is somewhere here. There's the difference between saying I have something on my desk and I have something in my house. This bottom one here this is what's on my desk, and this top one here is what's in my house somewhere. I know it's there. It's somewhere, and it's so relevant to my life right now. It's somewhere in my house. Just go find it. And this is directly on my desk, which actually at the moment doesn't help me too much. It's probably just as messy as the rest of my house. But that's that. My computer is lagging like you would not believe. Just gonna quickly check what's eating up all my CPU. Oh, it's OBS. Thanks, OBS. Anyway, so that's it. That's your first line of code. Now, when you actually go and compile this first line of code will come I think it's like 15 or 20,000 lines of code. And I will show you that at the end, just to show you what this actually does. I think I actually did show you in number 2, but I will show you as well. So we know now, actually I didn't actually explain what Iostream can do for you. Iostream contains a bunch of functionality that allows you to put text on the screen and also take user input from the screen in the form of a console window. So if you think of command, this guy here. Whoa, whoops. Fuck, I hate it when I do that. You think of that guy there, CMD. That is the kind of thing that this program will make with Iostream. Just a simple command window. You can type stuff and hit enter and it'll work. So now we have to get to the part where we actually put things on the screen. Now, computers, as I mentioned, aren't really the smartest things. You have to handhold them quite a lot. And the reason that is because computers can't actually think for themselves, which is good, because you've all seen Terminator, I assume. And for a program to work, it needs to know where to start. So back to the key example, could you imagine if I just gave you a set of keys to a robot and says like, go start a car? Well, I don't know how, you haven't told me what to do. So we have to actually explicitly tell the computer where the program is going to start. Now, that is what's called an entry point. Makes a lot of sense, I think. So we are going to have to tell the computer that we're going to start a program here. So how do we do that? We have a function in C++, and I'll explain functions as well, called main. Now, main is the standard, this is where the program will start. You are only allowed to have one main function in your program, and it has to be exactly one. If you have less than one, if you have more than one, your program doesn't work. It's as simple as that. Because, as I said, computers don't know how to think. You have to tell them explicitly what you want. Excuse me. Now, that raises the other question. What is a function? So a function is, in very broad terms, a collection of instructions to achieve a goal. So think to your life in general. I talk about cars a lot for some reason when I get to this stuff. One function that you, as a person, if you were of the age and you know how to drive, one of the functions you could do is drive to somewhere. So in that case, you'd have a function called drive to. And I'd be able to tell you where you want to drive to. That is a function. I could tell you to open the car door. That is a function. I could tell you to start the car, stop the car, accelerate, brake. They're all things you can do. They're all functions that you are capable of. That all happens internally. To accelerate, you put your right foot onto the accelerator and you press down. Or left foot, or hands, or however you want to drive. Those are all the details of the function. Those are all the instructions of that function. And that is how the code works. You have instructions that are smashed together into a function. And then you can call functions. You can tell the computer to do different functions at different times. So with everything in coding, everything needs to be set out a specific way. And there is a little bit of room for interpretation on the way some things are set out, like in terms of style, how things look. And I'm going to go through a little bit of the best practices stuff with you now as well. Things like this, the include, there's not really a lot of room for interpretation. They have to be done in a certain way for the computer to be able to recognize it. It all needs to be on one line like this. I mean, you can have a bunch of spaces there and a space there and one space there and make it look real fucking ugly. That's fine. But as I said, as you can probably see, if you have any kind of like eye for design or OCD, that's going to drive you fucking mental. So let's just get rid of that because it annoys the shit out of me. With a function, there are some certain things you have to do, and then some certain things that you can sort of interpret the way you want. So let's go and write it, and then we're going to go through it. So to write the entry point, we're going to go int main, open close parentheses, open close curly brackets. So let's go through from start to finish once again. Apologies again for the edit. My voice, once again, is on actually fire. It's literally on fire. So let's go through this from start to finish, and this is going to be a lot to take in, I think. If you've never done coding before, or have never done any kind of logical thinking or anything like that, this example is going to take a while to go through. And it is one of those things that it's extremely simple after you get it, and you'll look back, it's like, why does it take me a day and a half to understand? But trying to understand it can be a little bit scary. So I'm going to go as slow as possible, and I hope this all comes out the way I hope it comes out. So we have 2 words and a bunch of characters. The first word we have is int. Now, int is short for integer. So let's bring up notepads. Int, integer. What is an integer? If you've ever done some kind of math, you might have heard the term, or at least higher math. I don't think they use it in normal math. But an integer is just a number. A number basically without a decimal point. So something like 1 or 58 or 69 kappa. They're all integers. A number like 1.1 is not an integer. A number like 0.3 is not, or 0.32 is not an integer. 0 is an integer, minus 10 is an integer. They're all what an integer is. Now, that is what an integer is, but in the case of coding, what does int actually represent? So this is what's called a data type. Now, a data type is how, well, it's a few things. Firstly, it is a type of data. Don't ever quote me in the dictionary. It's never going to end well for anybody. But a data type is basically how a piece of information is modeled in memory. Now, there are a few data types that C++ actually give you, and most coding languages will give you the exact same things. The most common one, or the most simple one, is integer. Well, one of the most simple ones, I'll say, is integer. So an integer represents a number in binary in memory somewhere. If you've never done binary math, don't worry about it too much. It does help certain things, but all in all, it doesn't really matter too much. As long as you remember that the way things are laid out in memory are in binary, and you can run into some headaches if you don't account accordingly to the way numbers work in a computer, then you'll be fine. Just keep it in the back of your head. And if you haven't learned binary math, it is a good idea to go and learn how binary works. As much as I'd love to go into it, I think it is kind of outside of the scope of what I'm trying to do here. So we're just going to skip past it. So in the case of this, we're using a data type of integer. Now, just as a quick example, some of the other data types you can have are something like a bool, which is short for a boolean, or boolean. Apparently that's another way to say it. Now, once again, if you've done any kind of higher math, you might have heard of a boolean. A boolean is something with two states. In the case of a computer, they're labeled as true and false. This is an insanely important thing when it comes to computing, is a boolean. Think about your daily life. You want to go, okay, and I get in my car. I'm in my car now. Where am I going? I'm going to work. Okay, cool. So you start your car. Before that, you go, okay, is my car started? Yes or no? True or false? It's not, so I'm going to start it. Okay. I'm going to check my fuel gauge. Do I need fuel? Is my fuel above or below a certain threshold? True or false? These are all Boolean or binary choices, and this is the way you make a program flow. You have these branching paths you can take in a program that tells it what to do when, basically. And you achieve this using bools or booleans. This is not something we're going to go into in too much detail, obviously, at the moment, because it's a little bit outside of the first lesson. But once again, that's just another type of data you can have. It's just represented by a 1 or a 0. Very simple. And then you have stuff like char, which is short for character, which is basically just a single on-screen character. So the number 1, the letter Z, a comma, an exclamation point, the grave key, or is that the grave key, tilde, whatever that is. Or even something like when you press enter, that is a character. It's not something you actually see, but it is something the computer can interpret as a character. So it is a single piece of on-screen information. Once again, I'm not going to go into too much detail until we actually get to using them, but that's just something to keep in mind. So why have we got an integer here? That is something I will explain to you in just a moment. It becomes relevant sort of a little bit later, so we're just going to move on ahead and we'll come back to it, because otherwise it's not going to make much sense. Now here we have main. What is main? Baby, don't hurt me. Main is the function's name. Now, in the case of making pretty much every function in your entire program, you can call it whatever you like. It can have caps, it can have no caps, it can have, with some exceptions, it can have numbers. I think even some programming languages accept emoji as part of this stuff, which boggles my mind because that is so awkward to type. But in the case of a function entry point or a program entry point, it needs to be called main, and this is what I was referring to before. A computer needs to know where to start, and where it starts is the function called main. So, then we have these two brackets. Now, these represent something that is extremely important in doing functions. But, and here's the thing, but, we aren't going to go into them just yet because it does represent something a little bit more advanced. So, we're going to ignore the function of them, and we're just going to say you need them. These signify that what you have given this thing is called, it's a function. Now, that doesn't make a lot of sense at the moment. I promise you it will make more sense as more stuff comes out. So, why have we structured this like this? The accepted syntax of a function and of basically a lot of coding is set in stone. It needs to be a certain way for the compiler and for the program to be able to be interpreted by the computer. Sorry, we say that one again. It needs to be structured in a certain way so the compiler can interpret it for the computer. It's close to the truth. It's close enough for where our purposes are now. If I was to rearrange this and say main int, it's going to crack the shits at me. When you see squiggly lines on someone's Visual Studio screen, that's them getting the shits cracked with them by Visual Studio because you've done something wrong. Modern IDEs, the interactive development environments. Interactive? Oh my god, I can't remember the word. IDE meaning. Guess I'll edit that one out as well. Integrated. Oh, why do I always forget that? Modern IDEs have a lot of really cool features, and one of them is being able to sort of go through your code as you type it and tell you if you've done something wrong. It's pretty accurate for the most part. So when you see red squiggly lines, just at least after you've finished what you've typing, if it's still there, you've done something wrong. So the way this syntax works is, so let's go back to our notepad. We have int main this. So the int is the data type that will be returned. So think about that in the case of me asking you to tell me what 5 plus 5 is. You're going to tell me 10. You've returned to me a piece of data. It's an integer. So this is telling me that this function main will return to whoever's asked it to be run a piece of data of type integer to return. So once again, like, try to relate as much as you can just to normal life, because a lot of it does apply, and it will help you get that critical thinking and that logical thinking going to the point where you'll be able to break down a lot of what you're doing in life and go, okay, I could probably write a function for all this stuff, and I could probably collect all this data in such a way that I could write a function. Apologies for that. So yeah, a lot of how I learned how to logically think in the way a computer needs to think is to just sort of break down real life things, like the car example, how you go out and actually drive, how you go places, and what kind of data you need, what kind of data you give back, all that kind of stuff is how you can sort of learn to change the way you think, the way to train your brain to be a programmer. I found that a lot of people who try to be programmers can't sometimes switch their brain to thinking in that more robotic and logical sense. And it is something you do need to train. Your brain is a muscle. You need to train it to do it the way you want to do it. To have that kind of pure logical thinking is very weird, but it is something that you need to know how to do to be a decent programmer. So, let's go through the rest of the main example here. We have the word main. So, int here is the data type to return. Now, generally you don't make comments like this on a notepad document, but I don't want to sort of overburden you with any stuff, so we'll leave it there. Main, this is the name of the function. Usually can be whatever you want. In this case, it's the entry point, and it needs to be main. Now, I'm pretty sure, I could be wrong, that if you did like this, I can't remember exactly how Windows interprets this, that is actually incorrect. At the very least, in the case of something like this, that is incorrect. Most programming languages are what's called case sensitive. Just like your passwords, the uppercase and lowercase have to be exactly as you'd expect them to be. Now, if you've used Linux before, it's the same with file names and stuff like that. But C++ is very strict on this. Usually, with the exception of making Windows programs and you reading Windows files, which is a very small subset, which you shouldn't be getting lazy at that point, everything is case sensitive. If you use a capital M and you mean a lowercase m, the program will not compile or will not do what you expect it to do. So, don't do that shit. Leave that in the back of your head. You need it to be the right case. All right. We haven't explained the curly braces yet. We'll do those in a second. We'll go to the parentheses. What do the parentheses mean? Now, in the case of this example, because there are more things you can do with the parentheses. They're not just there for the sake of it. You can actually put things inside of them, just like you would normal parentheses. But we're not going to for this example because I think you're going to be mind-fucked quite enough. This, for the case of this example, it signifies that this is a function. Now, why would you need to signify that this is a function? Very good question, which we will work out in just a little bit. But there we have it. That is your second line of code all done. That is an extremely simple line of code. You will write something like this 1 trillion times if you become a software engineer. And every time you'll be like, I know exactly what I'm doing, blah, 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 blah. Done. Easy. Now, the last thing we did here were these curly brackets. Now, the curly brackets have a... Apologies again. Now, the curly braces, they have a very specific function, and thankfully it's a very singular function. And once again, these are something if you do any kind of C-based programming, and maybe some others, I can't really remember off the top of my head, you will use these a lot. The curly braces indicate a block, or a block of code. Now, for the most part, when you do this, the block relates to whatever is the line above, or the last statement, I should say, because that distinction is extremely important. So in the case of what I've done here, what this is saying is this block of code in between these braces is the function main. Now, you could imagine that if you didn't have these curly braces, the program wouldn't actually know where you're starting and stopping this function, or where does the next function start, or where does something else begin. It won't know. Of course, once you get into a bit more complex things, it comes, most of the part, pretty self-explanatory, but it's not always the case, and computers need to be explained everything to the last detail. So, curly braces. Curly braces are a block of code, generally relating to the statement beforehand. Now, statement is a bit of a nebulous term. It can mean a lot of things. In the case of what I'm using, statement is just the bit of code before it. Depending on, once again, how you use the word statement, it can mean different things. I don't think there's ever been a consensus to how you use some of these words, or maybe I'm just an idiot, but that's the way I'm going to use it. So let's just recap on what we've written here. We have a function with the name of main, so this signifies it's a function, and that's the name. It's going to give back to the person who asked this function to be activated, to be run, some data of type integer. And everything between these two curly braces is what will make up that function. Once again, this might sort of not click straight away, mostly because I'm trying to teach it in a different way, but I hope it does. And if not, this will all seem extremely simple at some point, hopefully. So what we have written here is actually something that will run. If I hit the play button, it will actually build. It will say it's building main.cpp. It's created an exe. It's actually just run. Why is my phone going off? It's raining pretty badly outside. It's setting off my motion alarms on my cameras. All right. I don't remember where it stores the stuff. Okay, here. Cool. We can actually see we have an executable called lesson3. Let's run it. Now, if you've ever done any kind of command line funkiness, and you want to try this for yourself, if you click into the title bar of the text box and type in CMD, it will actually open up a command window with the folder set to where you just typed it. So you don't have to go and path to it. Because if you open it through like the run thing, you'll see I'm in my user folder, and over here I'm actually in my code folder. If you haven't done any command line stuff, I mean, you really should. I mean, you're not going to use it a terrible lot as a software engineer, but as like general IT skills, it's something that you should do. And general IT skills is something you definitely want when you're a software engineer. So what we're going to do here is tell the computer to actually run the program we just did. And it's now returned back to the end, and nothing's happened. But it ran. It just did nothing because we haven't told it what to do yet. We've given it a bunch of stuff it can do, but not actually told it to do anything. So let's fucking tell it to do something then, eh? We're going to write something to the screen. That is what we're going to do. And once again, this is going to be one of those things where I'm going to have to type it out and then sort of go back on it, because there's no real way you can sort of go, this word means this, because it needs context. So let's, hello world, type it out. You didn't see that. Let's type it out, and let's actually run it. So, well, let's build it, because we'll run it. So that when you hit the play button, it does build and running, but you can also do the two things separately. You can build, and you can start with or without debugging. Now, debugging is something I think I went into a little bit at number 2, but we'll go into that a bit later on. It's not something you really need to know about right now. So let's run it. It disappeared. Let's run it through the command window. Look at that. Hello world. We are programming. How great's that? Apologies once again. My throat is really trying to kill me today, and it's going to make me edit a lot of this stuff. So we actually have some text on screen that says hello world. We have told the computer to do something, and it has done it. Oh, glorious day. We are programmers. We are the best people in the universe, and we have created Skynet. So let's go through and actually work out exactly what we have done. And we're going to sort of break it down into as many steps as possible. So if you haven't read all this stuff, I'm about to... I mean, I really shouldn't delete it. I won't delete it. I won't delete my text file. I'll save my text file. This will be a function. I might put this up on like GitHub or something, which won't help because I haven't talked about source control. But anyway, I'll give you a link to whether you can download this stuff below. And we are going to wipe that away. And we're going to go, all right, let's break all of this down. So we have quite a lot going on here. It is an extremely complex statement that, when broken down, will become like, this is really fucking simple. So, what do we have? You'll notice that we have std there twice. We have 2 sets of double colons. We have 2 sets of double angle brackets. We have some text inside of quotation marks, or whatever they're actually called. And we have a semicolon, and we have 2 words, cout and endl. And I will go through all of these in good time. So let's go from the start once again. We have this entire statement here. std : cout. This is a lot to take in, and I'm going to be using a lot of real-world examples here, which I hope hit home in such a way where it sort of makes you understand what's going on. So let's go back into Iostream for a second. Where are we? Open Iostream. It's going to make me look bad, isn't it? A little bit. Yeah, fucking hell. Sometimes I hate the way some people do stuff. We won't go back into that. Let's just ignore everything I just did. So, the way... We'll go to the double semicolons work first. The way the double semicolon works, and what it actually does, is it's saying that the thing after the double semicolon is in the thing before the double semicolon. So think of it much like a folder full of smaller like pieces of data. So you have a folder called std, and I mean folder as a binder, not as a folder as a computer folder, but a folder as a binder. And you have the little tab things. And each one of those tabs represents something. You have one of those tabs called cout. Now inside of cout there'll be more instructions on your little loose leaf paper, but we won't dive into that too much. So what this is saying is, inside of the binder or the folder or what it's actually called in C++ is a namespace of standard. Inside of that is a thing called cout. Now what that thing is determined by what you're actually trying to do with it. In the case of this, and we can go into it, it is a piece of data. But it's a special piece of data because I like to fuck with you. We're not going to go too far into it, but what this actually represents is something you want to put out onto the screen or onto the command line here. So whenever you want to put out things onto the command line, you have to use this or something like this, but we're not going to go too far into that. There is more than one way to skin a cat. That's all you have to remember. There is more than one way to do literally everything in coding. So this piece of data here represents our screen, basically. So what do the two arrows represent? Well, the two arrows actually represent a function, much like main that we have written here. This is a special type of function called an operator. Now, if you've done, once again, any kind of higher math, you might have heard this term operator. Operators can be something like the plus symbol, or a bracket, or the divide symbol, or the two arrows, or anything like that. And what this does is, it signifies, it's more of a natural language kind of way to write a function, or to call a function, to actually make a function activate. In the case of this one, what this function says is, and once again, this is extremely specific to what you are doing. A lot of this stuff is extremely relative to what you were doing at the time. So in the case of a plus, if you have two numbers, you could probably interpret what that does. If you have two pictures and you do a plus, what is that actually going to do? Under the covers, you don't know actually what it's going to do. In your head, you might have some example of, like, if I see picture plus picture, it might actually just put them next to each other and make one big picture. That makes a lot of sense. And it becomes a lot easier to sort of very quickly go down the page and read what's going on. That is a lot of what operators are meant to do. So we could easily do cout.output to screen hello world, which I know I just jumped ahead. You know, something like that, to make it call a function that's called output to screen. And it does make a lot of sense, but it does take just that little bit longer to read. And when you're going through, you know, tens of thousands of lines of code a day trying to find something, you want to be able to go through it as quickly as possible. And that's why people have invented stuff like operators. And because it is a universal language. Plus could be plus, addition, combine, like any of those kinds of words. But a plus, you know what that's going to mean in context of what kind of stuff you have around it. Now, in the case of this one, in the case of this very specific example, and I will say this again, in the case of what we are doing now and this very specific set of things, this is what it means, okay? Please understand that it's all very relative. What this means is the thing on the right is what I want on the screen. Please push it onto the screen. And if you look at it like two arrows, it makes a lot of sense. Smack it onto the screen. Hang on, I'm going backwards. Smack it onto the screen. So what is after the line? We have hello world inside of two quotation marks. Talking marks, as I learned in grade 2. I don't know if we need that up anymore. We're going to talk through it. So what do the quotation marks mean? The quotation marks is a way for the computer to go, what is inside here is text. It is not something that the computer needs to interpret, the compiler needs to interpret as code. It is something that is in natural language. It is just English. It is letters and numbers and whatever else. Don't worry about interpreting that. Just take it as a piece of data. This is what's called a string. A string is a string or a combination of characters. Now, this is another thing that you will use a ton. Now, think about all the games or all the programs you've ever used that has some text come to the screen. Every one of those is a string in one form or another. And what we have written here is saying, okay, we've got 2 quotation marks. Everything inside there is text. Hello world. Now, it actually comes up with a few funky things here for you. And if you hover over a lot of this stuff, it'll give you a lot of information that I would recommend at least having a bit of a look at, like what you can actually hover over and sort of try to make sense of. But don't worry about it too much. It doesn't really matter if you don't understand the underlying bullshit going on. We will go into as much of that as possible. So this on its own here is saying, please put hello world onto the screen. That is the English interpretation of what we have just done. And I will actually break it down for you. So standard is what's called a namespace. Now, the standard or STD namespace, the naming, once again, is arbitrary. But all the stuff that comes with C++, once again, depending on what version of C++ you're using, will be in the standard namespace. Things like reading and writing from the console, reading and writing from files. I have forgotten a lot of things like sorting algorithms, stuff like that, and specific things to hold like large collections of data are all in the standard namespace. It's just like their way of saying, we've written a bunch of shit for you, here it all is, go nuts. To explain why we use namespaces is actually pretty simple. So think that you have a bit of code that you've written a function to sort something. Now, there are about 1 billion different ways you can sort something. Like you can do like bubble sort, selection sort, stupid sort, which is actually my favorite, and you should definitely look it up if you've never heard of it. The basic interpretation is, think if you've got a deck of cards and you've shuffled them and you want them in order, and stupid sort would be throwing them up on the ground, up in the air, and picking them up one by one. And if they're not in order, you just throw it up in the air again and start again. Fantastic. But then I'm going to go write a sorting algorithm, and I'm going to call it sort as well. How does the computer know? Go away, virus scanner. I know I have to update my goddamn license. How does the computer know which one it wants? The namespace is what tells you which one you want. You can go into the standard namespace, you can go into the JSON namespace, you can go into the user namespace, or whatever else you want. Whatever arbitrary bullshit. It is just a collection of data and functions and operations and whatever else that you want. That is why we use namespaces. And they become extremely important when you start doing very generic things, but in different ways. In the case of a sorting algorithm, once again, that is extremely important because I might do it differently. I might use bubble sort and you might use selection sort, and they're both very valid. And they might have different ways to do it, depending on, they might have a better application for what you're doing in one thing than it is on another, and then vice versa on the next thing you're trying to do. And you don't want to have to sort of write that code locally or dick around with your code. You can have it there, ready to go, in a file, much like Iostream that contains all my code somewhere else, and just sort of call it whenever you want. So that's why we use namespaces. Once again, think of it as like a binder. If you've ever been to like an accountant's office or a lawyer's office, they have hundreds of binders. Binders full of women. God, the memes stop. And that is, they'll all be labeled. This is financial year 2017, A through Z or A through B receipts or something like that. There might be a receipt from person 1 under A, and then under B it's like person 1, and then under C it's person 1. Why that would be, I'm not sure. But it could be there. So that's what that is. The double colon is saying look for thing on right in thing on left. It's an extremely basic interpretation, but I think it works. cout. Now, once again, when you name data and when you name functions, when you name basically anything, it can be whatever you want. But when you are using someone else's pieces of data, it needs to be exactly what they have named it. If I tell you to go to your bedroom and you've actually named your toilet the bedroom, we're going to have a bit of confusion. If I tell you to go to the boudoir, you're going to be like, what the fuck is that? Oh, it's bedroom. Why don't you just say that, you absolute plonker? So cout here is a piece of data. This is a very special piece of data in very basic terms. Once again, this is not exactly correct, but we're trying to get sort of broad strokes going here. A piece of data, it will represent output to the screen. That's what it is. Think of it as this is the literal interpretation of this console window. That is what that is. Then we have the two angled brackets, whatever you want to call them. This is what was known as an operator. Once again, we'll go through it just quickly. An operator is just a special type of function. It is a representation so that it's very universal. It's much like a plus or a minus. You know, a plus can be called plus, addition, combine, or whatever else. And the minus can be minus, subtract, take from, take away. But in the end, they all mean exactly the same thing. And the minus symbol, which is this one here, is just a visual representation of this. So that when you're reading this code, it comes to you straight away. And it just makes a lot of sense. It's usually, you know, in context, it makes a lot of sense, I'll say. So in this case, this operator just means shove the thing on right to the screen. And once again, it does look like a bit of an arrow, so you can kind of interpret that like that. There are other uses for the angled brackets, and of course there's a mathematical use of a single angle bracket, less than and more than, but we're not going to go too far into that. Let's break down hello world. So first we have the two quotation marks. This is just saying this is not code, this is text. Because otherwise, if we got rid of these things, it's going to go, what are you actually telling me to do? I don't know what hello world is. Hello is undefined. I don't know what world is. Well, I expected that. But we'll go into that. So it's just saying this is actually just text. The cout, it's expecting some form of text or numbers to go out onto the screen. That's how it needs to, that's how it knows to put things on the screen. If you give it, I don't know, a file, or if you give it a sound, or an MP3 or something like that, it's going to go, what the hell are you on, mate? I don't know what you're doing. So it needs text. That's what hello world is. And hello world is the text. Let's make this a little bit wider so it's on one line and just satisfies my OCD. Then once again, we have another set of angled brackets. This is the exact same as the thing above it. It's saying, please put also this next thing onto the screen. That's it. That's all it is. Same as last one. So we can do something like this. We can go, hello world, hello me, hello you, hello you. And we've already figured out that it doesn't stay on screen, but we'll go into that in a little bit. So let's build it. It is hello world, hello me, hello you, with no spaces because we didn't actually give it spaces. We can fix that, but we're not going to because this is a very stupid example. Control-Z is your friend when you're a programmer. The amount of times I just mash Control-Z until it starts working and then I very, very slowly redo the things I just did. It's like, oh, this is where it broke. Now it makes sense. So then we have this last thing. Now we've already determined what STD and the double colon is. STD is same as before, double colon, same as before. We've already gone through those. They still mean exactly the same thing. The great thing about coding is if you do something twice, they're generally going to do exactly the same thing. We have this endl. Now this isn't strictly necessary for this code. I could have left this out and made it a bit easier, but I wanted to introduce you to a few more concepts. So endl is a piece of data, and it isn't an actual special piece of data, it's just a plain old piece of data. let's go into it and actually tell you and show you what it is. It's going to be a dick. Kind of not. So end L is kind of shitty in a way now that I look at it. But what it is this. Now you notice a couple of different things here. So let's just put this into Notepad again. And I will go through it with you. It is a single quotation rather than the double quotation. So single quotation with a slash and an N and another single quotation. So let's break this down a little bit further. Now up here we had a double quotation, and that hello world in between. Double quotation means everything inside this is a string. A string by design is an arbitrary amount of text or characters or anything like that. A single quote, it's actually in the name a little bit, is a single character. Whereas this is a string of characters, this is a single character. Now I know you're looking at that and like, what? That's not one, that's two. It's \n. That's two things. This is where programming gets fun. Backslash is a special character. And what it does is it says the next thing that comes, and this is pretty much true for nearly every programming language I've ever used. When there's a backslash, the next thing that comes will be interpreted as something special. In the case of /n, it interprets it as one of those boys pushing enter, a new line. So then you look back in end L, you go, oh, end L, does that say end line? Yes, it does. End L creates a line break. It moves the cursor down to the next line. Think of it like an old typewriter. You hit a ding and you slam it back. That's you end L. It moves the paper up and you start typing on the next line. Much like if I did this, like that, we're down on the next line. That is end L. If you open up this in a binary editor, so you can actually see what it looks like represented in memory, it'll actually have a /n there, or the binary interpretation of a /n, which is a new line character. There are quite a few slash characters. There's /t, which is the tab button, so you can go over like that guy if you've never used tab. I'm trying to think of other ones now that I'm completely drawing a blank. So in the case of this, if you wanted to put in a double quote, it actually ends it and it doesn't know what's going on. So you'd use a slash to say, no, the thing after this is a special character, but it's just literally what it is. I know, it's really confusing and I apologize, but it will make a lot of sense at some point. And it's the same goes if you want a backslash. If you want a backslash in there, you have to type it twice. It's saying, the next thing's a special character. And what's that special character? A backslash. So what does that get interpreted to? It's just a backslash. This comes up a lot, especially with like Windows file paths, as you notice there's a single slash. So when you start hard coding that stuff, it becomes a little bit complicated and a little bit messy. But I'll leave that in there and I will show you what it looks like. You can see a single slash there. So let's remove that again. So you can see the end line character here. You can see we've actually gone down and created an empty line just there. Now, in the case of this program, it's not very useful, but you can think of if I'm going like this, hello me, hello you, hello everyone, oops, everyone. We'll delete those two. My computer is running a bit better. We open it up again. You can see how that's a lot neater than having it all on one line. Or, any kind of text document. You don't really want everything on one line. You want to be able to break it up. That's when that comes in handy. With a single line, once again, not the most handy thing in the world. But now we're at the end of the line. We're at the end of our first actual line of instruction code to a computer. And that is the semicolon. Does anyone want to guess? You're right. You, Tommy, you're right. I hope I freaked someone else and that'd be absolutely hilarious. What this signifies is the end of a line of code. That's literally it. We have now So let's just see that example. We have ended our line of code. You can see there are a few distinct instructions here, and we can keep going on forever. Hello, blah, and on and on and on forever. Yes, this underline is just my spelling check because hello is apparently not a spelt word properly, a properly spelt word. Wow. So the semicolon just says, cool, cut it, we're done. Every line of code, give or take, because you can see we haven't got any semicolons here or here. Basically, every line of instruction code you write needs a semicolon at the end in C++, with extraordinarily few exceptions. And I actually can't think of any at the moment. Let's remove that. And there we go. That is our first line of code. Now, the keen-eyed among you, maybe, hopefully at least one or two of you kind of gone, well, what about this little int guy here? We haven't actually given anything back. Why is that? Sorry about that. So we haven't actually told the person who called us this piece of data back. Now, generally, and this is true for literally every other case, generally the computer would complain at you for not doing that. It's expecting you to give it data, but you haven't. So you're a fucking jerk, and it will yell at you. Of course, this is a special example because this is main. Main does some very strange things and allows you to do some strange things. You don't actually need to give it back a piece of data. We've told it is, we're kind of giving it like data blue balls, but it is what it is. In the case of this example, I do want to give it a piece of data back, just to show you how. And I'm going to tell you about why this is an integer and how things are interpreted. So, we're going to write another line of code. And I've said the word, and I think we can kind of go word by word here. There's only two words and then a semicolon. So we'll do that. Now, if I tell you to go and retrieve something, if I tell you you have a function called retrieve, I tell you what to go and retrieve. And the return type or the data type is an int. You are going to return that piece of data to me. And I've said a return quite a lot because that is what actually the C++ word is to give data back to thing. It's actually called return. So how do we write that? Literally return. You see the nice bold blue color? That is a C++ keyword, or it is a part of the C++ syntax. Those are the basic building blocks of the code. So things like return, if, int, things like that. Once again, we'll go into that a bit more as we go along. But C++ is actually what most programming languages give you very little to start with, and then they also build a bunch of crap in the language that allows you to do all the fun stuff that you actually need to do with programs. So what are we returning? What are we giving back? We're giving back an integer. What does the integer mean? In the case of Windows programs and basically any programs, when you return an integer, if it is 0, you're all good. Shit's gone well. We've done exactly what we needed to do. If it returns anything but 0, that is an error code, and we need to interpret that. You might return the error code 1 saying you've forgotten to tell me an argument. Error code 10 is file not found. Error code -50 is I ran out of memory. It doesn't matter. It's all relative to the program you're writing. The ability for you to grab that error code and then interpret it, that's all on you. What you're doing is just telling Windows that here is a piece of data, can you please give it to me later? Now, we aren't really doing a whole lot. We're displaying stuff on screen. If we are displaying something on screen and we've gotten to the point where now we're giving back data, we've actually done it successfully. It's a really hard word to say. Successfully. So we're just going to return the number 0. That's our piece of data. And that's the end of our line of code. And that's really it. That is how you give a piece of data back. Now, this is a very, very simplistic example. A number isn't the only piece of data you'll ever want to give back. If I tell you to go get a phone number, I tell you to go get someone's name, I tell you to go get someone's photo, those are all pieces of data you can return to me. So once again, this is a very simplistic example, but I think it does teach a lot of the very basic ideas of how programming actually works. And now that we've sort of gone through that and it's taken like an hour, we can actually go through about a couple of other things to do with this, like best practices with style and how the program actually flows. So I think we should do that one first. I'll make sure I haven't missed anything in my... No, I haven't. Yes. So a program is interpreted just much like you would read a book. Top left to bottom right. It goes from the top first character and goes down, 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 and does it one by one. The way stuff works, so you can sort of jump around and go, okay, I'm 20 years old. I'm going to go out tonight. Or I'm 30 years old. I'm not going to go out tonight. That one's pretty accurate. You get those branching paths. You actually have ways to jump around the code. But that's still going from top to bottom because that one there goes jump over there. And then you're going to go over there and go top to bottom. That is how a program actually flows. The way you read it is the way things happen. The way you would read a book is the way you read code. And this int main is where it starts. It doesn't matter where on the page this actually is, that is where it starts. If I have another function up here, int blur, the program still starts at int main. We won't go too far into that again, getting ahead of myself a little bit, but we will do that. And I also promised to show you how this actually looks when the preprocessor goes through it. So let's do that. Could you not be shit? I actually hate this thing forever and ever and ever. But that's fine, it actually worked. This is the .i file. This is the preprocessed interpreted file. This 7-line piece of code turns out to be this. 54,814 lines of code. And you can actually see what it says here. Line 2 of my program starts at line 54,807 of this file. Could you imagine trying to manage the copy and pasting of this garbage if you didn't have the computer doing it for you? This is all necessary, for the most part. To get this little hello world to come up on the screen, you need to have all this 55,000 lines of code. Could you imagine manually managing that? That would be a pain in the ass. And you can see my little pissy bit of code here. This is all that include function. Why is it so big? We open up Iostream and this is only like 50 lines, 59 lines. But there's another include, and how big is that one? And there's another include, and how big is that one? And then there's probably, there's another include, how big is that one? And there's another include, how big is that one? And there's 5 includes there, how big are those ones? You can see how what the point is here. It's all cascading. These are all things that need other things, that need other things, that need other things. Much like in life, to know how to drive, you need to know how to, well, I guess you don't really need to know how to read, but that kind of helps when you're going through street signs and stuff. You need to know how to determine your speed, you know how to use your legs, you need to use your arms, you need to learn how to see, you need to learn how to steer, you need to learn how to change the radio while you're driving because some shit's come on that you don't want to listen to. These are all things you need to know to drive. And these are all things that you can't compartmentalize much in the same way, I think. So that's how that works. That include thing is literally the greatest thing to come to programming in my eyes, because it's a lifesaver. Now, I promised to talk about best practices a little bit and things that are up for interpretation, because a lot of coding is extremely rigid, the way things need to be set out. But not always. And the way I've done it on screen is the way I like to do it. And I generally think the way I like to do it is actually the more accepted, kind of everyone does it this way kind of thing. But I do want to show you some of the other ways to do it. And it begins with these curly braces. Now, it doesn't really matter where these curly braces are in relation to the statement before it, just as long as literally the last thing that happened was the thing that this curly brace relates to. So if I do this, and I have 20 lines of nothing, that's still perfectly valid. It's ugly as fuck and really hard to read, but the computer doesn't care. The compiler actually strips out all of the white space. So, except for things like hello world here, this space, if you have more than one space, it's going to add more than one space because it's just data. It's not actually the code at that point. It strips out white space from code. I should probably put that little asterisk there. Now, the reason I lay this out like this is because in future you have blocks inside of blocks inside of blocks inside of blocks. So then you have like this. And you can see very, very easily, like if I have, just going to put this there, and there, and there, and there, and there, and there. You can see very easily what block of code this all relates to by the indentation, how far over on the screen it is. And then the curly braces is always on its own, and then the rest of the stuff is indented in. To me, visually, that's very easy to see. I apologize you see the screen flashing on. I think I keep kicking the power cable out. My floorboard's a bit knackered. So this is the way I like to do it. But one of the more common ones besides this is something like this. Now, to me, look, I understand it removes a bit of white space so you can display more on screen. But I can display, at 133% zoom, I can display 37 lines on screen. If I zoom out to 100%, like 52 lines of code on screen. That's a lot. You generally don't have functions that are that big, generally speaking. Just don't watch my Yandere dev stuff if you want to not see things that are huge. So saving that extra line, I don't think is really worth it. There are some reasons why you would want to. If you're doing stuff like you have to send over the network, then you want to have it as small as possible for efficiency's sake and for speed. But this is not. This is all local. It's all interpreted before the computer gets to it. This, and this all come out exactly the same in the end. So that's style. It's all about the style. What you choose to do, go ahead. As long as I don't have to read it, I don't give a shit what you do. You could do it like this. You could do it like this. If you really want to hurt my feelings, you could do it like that. But it doesn't matter. Once again, this is about best practices, not just for everyone in general. Like if you're working on your own, go ahead. Do it however you want. If you're working in a team, you generally want to either do industry best practices or there'll be some kind of style guide or something like that, which does sound extremely wanky. But trust me, if you're reading through tens of thousands of lines of code a day and they're all formatted differently, your brain's going to explode. Now, other things you can do to do with style. If I wanted to have these on a different line, I could, that's all fair. Wanted to have it like that and then like that, that's all fair. Oh, my monitor's just... Okay, can you stop? You're like lagging out my computer and it's giving me the shits. Just gonna not move my feet. That's all, it's all fair. If you can insert white space or a line somewhere, generally speaking, that's fine. I would actually recommend you play around with it and just sort of see what works for you. Of course, just like everything, there are exceptions. This is illegal. They need to be on the same line. But everything else is very much up to interpretation. I think that's actually all I had to talk about for this lesson. It's taken me nearly 90 minutes, give or take, without all the editing, to get to this point to explain 2 lines of code, basically. But I really hope you have more of an understanding about how this all works. And if you don't, I would recommend maybe reading over it again. Do the code yourself. Try to change, what the output is. Don't say hello world. Say hello whatever your name happens to be. Now, once again, I'm not going to go through why. Oh my god, I friggin' change stuff. Ignore that. Cool. So it pops up on screen and goes away. The reason it pops up on screen and goes away is because we're not actually telling it to stop. It's just going to go straight through and fall off the end of the code and then exit. It's finished. Which is why you need to do it in here. Because even though it's exited straight away and back to the command line, it's actually still displaying the results. This is very tedious. There are ways around it. But once again, I don't want to overburden you too much. But we will do a quick recap from top to bottom. Let's look up the first thing we did. No, that's not the first thing. This is the first thing we did. So, actually, I didn't even put down this first one. We are using this thing. This is the preprocessor directive. That's what the hash is. It's saying the preprocessor is going to do some shit. What the preprocessor is going to do is include something. What it's going to include is the Iostream file. Now, this is just a code file. This will be something you use a ton because you have thousands and thousands of files, because it's better to split things up into files. Just like, if you have a bunch of documents on your computer, if they're all one big document, it's really hard to read. If you have 10 documents, that's like receipt 1, receipt 2, log 1, log 2. You just refer to whichever one you want. If you need them somewhere else, you just copy and paste the stuff in. This is what it does. We have a function called main that returns an int. It gives the data back of type int. Once again, the name is arbitrary for the most part, except for the main function. Great example. We have the curly braces, which signifies a block of code, usually related to the thing above it. We are outputting hello world onto the screen. Cout is the computer representation of the console window. Cout is console out. There is also its counterpart cin. I'll let you try to interpret what that means. We're also ending the line. We're jumping the cursor down to the next line. You don't really need that in this case. I do it because it's when you're writing stuff like this, you put the end of the line so that the next thing that writes the code doesn't have to worry about it. It assumes there's a clean slate ready for it to go. And then we're giving back the data of 0, which in this case just means great work, we're done, awesome. And that's it. That is the hello world example. If you've gone all this way and you haven't typed anything yet, you need to get Visual Studio out and you need to type this. If I've put the links in the below, do not copy and paste it. Do not just run it. Type it. It'll take you all of like a minute at most to type all this. And the reason why you type some of this stuff is look what happens when I type in std and double colon. It actually shows you all the things that std has. This is Intellisense, and this is why IDEs are absolutely mental these days. It tells you literally everything you can do. And you'd actually go through some stuff and go, oh, I wonder what half this stuff is. We have current exception, and I don't know what the fuck that is. We have equal. That sounds pretty cool. We have end, end-l, end-s. Cool. We have a lot of other stuff. Is finite. Log. In a math file. Ooh, that might be the logarithmic function. We have log 10. Ooh, math. Cool stuff like that. Maybe you'll be able to figure some out. And then when you do cout and you do stuff like this, it goes yit. And then you do end out. Look, there it is. End out. Cool. But another reason you type it is it helps you commit it to memory. It makes a lot more sense in your head when you're actually typing it. So I would highly recommend you do that. This is my real first lesson in coding for you guys, and I really hope you have enjoyed it. I've enjoyed talking about it for the last hour and a half, I must tell you that. And I hope it has been extremely informative, and if there's something I have missed, just let us know below. I'm not going to Like the first two I've recorded before I release this one, but because this is actually the most substantial lesson so far, I'm going to release these before I record anymore, just to see if you guys think I've missed anything. Hopefully I haven't, but I guess we'll see. And I really hope to see you in episode 4, where we talk about data types, variables, constants, and how data works. It's going to be fantastic. We'll see you guys then.